Let's take a little while to talk about while. The while loop, or another control statement that we've been looking at the last few videos. While is pretty simple, but like many simple things, it can be used to produce some complex results. Now here's the while statement in its basic form. We have while and an expression. If this expression evaluates to be true, non-zero, then we will come down in here and we will execute these statements. Yes, if you only had one statement to execute, you could skip the braces because the braces are just going to bind these statements together into one block of code or a compound statement. You could say while something is true, do a one-liner that ends with a semicolon. But that's not very common, so you're most likely going to see it like this with the statements, multiple statements, other tests, other things like that going on inside the while construct itself. Let's take a look at a piece of code. Here's a little program that we'll play around with. We're going to put the computer in a cranky mood, and we're going to have it say, I bet you can't type in a 7. And we're going to set up a little automatic character called I. We'll set it equal to 0 because we're good programmers and we initialize our variables. And then we're going to start a while loop, and we're going to say while I is not equal to the character 7, not just a 7, make sure you get some single quotes around there. While I is not equal to a 7, which is what we told them they couldn't type in, we will get a character from the keyboard with getChar or getChar, depending on how you like to say that. But I is equal to getChar, and we do another little getChar here because in the programming world, when we take a character from the keyboard, the person has to press carriage return because we don't want to deal with trying to unbuffer the keyboard and accept characters immediately and all that, trust me. We just want to take in a character and a carriage return. So we need to pick up the carriage return and get rid of it, and that's all this is doing. So I is equal to getChar, throw that one away, and then we'll print out, you typed something, a character. This is the first time we've used printf like this, and we have a whole video coming up on printf later on, and it'll be nice and long, and we'll talk about all these things. But here, pretty basically, we're going to print out a character form of this value of this integer, or I'm sorry, this character that we created up here, which will have a whole number integer value. But we have taken it in from the keyboard. We will print it back out as a character rather than the numeric ASCII value that's stored in there. And if the while, see here's the bottom of the while, there's the top of the while, we take in the character, we hit this close brace, which means we go back up to the top of the while, and we say, is it what we were supposed to get? If the I is not equal to 7, this evaluates to be true, and we come back down into here and do this again, get another character, test it, yell at them again, and go on around. If we take in a character and it is a 7, they do put in a 7, we're still going to say, you typed 7, because we don't have any way out yet. So if they type in a 7, we're going to say this, so we're still going to be rude, even though they got the right value. We're going to hit this brace, we're going to come up here to this while, and it is now, this is going to be false, because I will in fact be equal to 7. This will fail, and we'll jump to the next statement, which says I'm done, and the computer goes home. So let's go take a look at that in code. There it is there in our notepad, while.c. It's all the same code, not equal to 7, and so on. And let's pop over here to our compiler, and I already have it in there. So we will compile and link it, and then we'll run it. And it says, bet you can't type in a 7. And if I say I put in an A, he says, you typed an A. If I put a 4, you typed a 4. If I put a 7, you typed 7, I'm done. And he leaves. All right, so that's exactly what we expected it to do. And surprisingly enough, the computer did what we told it to do. So that is a normal while loop. Very simple. It's a while with a simple test for inequality here. this expression just has to equate to be true. Remember that. You need to have a true result in there. Now, I want to show you a little different form of while, and that's an infinite while, an infinite loop. And that's my little definition, infinite loop, C, infinite loop. You see, it's supposed to be a joke. Anyway, here's our program. It hasn't changed very much, except that we're going to get a little closer to what we expect this little game to do. We're going to say while 1. 1 is non-zero, always true. This is an infinite loop. There is no way out of this loop once it starts. Well, we've got a way out. We're going to make a way out with break. We're going to break out of this loop. Control C will also work if you get a loop that runs amok on you and you forgot maybe to put the break in. You can send a Control C character in through the keyboard and stop the thing. So here we're going to say while 1, I is equal to our get character. Here's our carriage return. Soak up the carriage return, get rid of it. Now we do a little test. If I is equal to the character 7, break. Now I put braces around it, which we know from looking at the if statement is not exactly necessary, but I like to have them. And I didn't put this one down here like I normally do because I was running out of space. So it's okay. C doesn't care about the white space. The carriage returns. It's okay to put that brace up there. If I is equal to 7, get out of here. Break works on the latest loop that it's inside. Had there been another loop in here and another loop, the breaks keep track of what loop they're in. This break knows that it's inside this while. So when we hit that break statement, it knows to go to the next statement after the close of that while. So it'll jump us down to here and we print I'm done. If I is not equal to 7, now we can antagonize our viewer and say, ha, you typed in something else. That's our same line from before. And we come back around because we hit the bottom here and come through. But this time, it works a little nicer. If I is equal to 7, they type it in. We just leave. We don't bug the person anymore, even though they hit the right character. We just leave, and we say, I'm done. So let's take a look at this program. And it is in while2.c right there. It's the same code we just looked at. We have our infinite while loop. We'll pop back over to our compiler, and we'll compile and link while2.c. There we go. Now we'll run it. And it says, bet you can't type in a 7. If we put something incorrect, he yells at us, different letters. And if we do the 7, he just says, I'm done. Because before, remember, he yelled at us. If I scroll this up, you can see it here. He says, ha, you typed a 7, and I'm done. So we have different functionality, which is closer to what our original requirement was for the program, our original specification. Let's get back here. So that's an infinite while loop. That's a different way of using while by putting a hard-coded 1 in there, while 1, and just a little different way of using the while, and hopefully you understand it a little bit better.